I am in Delhi and we all are suffering. The air pollution this year has been devastating.
So whatever we burn in the central India, basically the smoke travels so across this peninsular southern India and it goes over like Mumbai and then it flies over Arabian Sea. And I have seen this smoke plume reaching Somalia.
There's a strong evidence that the farm fire is not reducing.
The farmers have changed the burning timing from about 1 to 2 p.m. to about 4 to 5 p.m. This downtrending that we see in the satellite data is started in 2022. And that's where the government change took place in Punjab.
Welcome to a brand new episode of COgreen, an iFOREST podcast on science, technology, politics, and economics of environment. Over the last 3 months, stubble burning has been in news, especially in the national media, because of the kind of air pollution Delhi has witnessed this year. And October, November, and even part of December had severe air pollution levels, one of the worst that I have experienced in my lifetime. And obviously, the discussion was on stubble burning. Now, the discussion became more interesting because government data showed that stubble burning has reduced by 80 to 90% in Punjab and Haryana. But there was other side to this story, which came from the scientific community. A scientist working on satellite monitoring were warning us for more than 2 years that the current monitoring of stubble burning is actually not capturing the true extent of stubble burning. Now, I came to know about this almost 2 years back. And because we have a team at iFOREST, which is also using satellite to monitor air pollution, and one of the things that we monitor is something called as aerosol optical depth. Now, our data was also showing that there was no reduction in aerosol optical depth over Punjab, Haryana, and Delhi during stubble burning season. Instead of decreasing, there was actually slight increase in aerosol optical depth this year during stubble burning season. So you now have two things. Government data, which is essentially claiming that stubble burning has reduced, and scientific data, which is actually contradicting it. In this first episode of COgreen, in the year 2025, I'm going to talk to Hiren Jethva. Now, Dr. Hiren Jethva is actually at NASA. He is a senior research scientist at Morgan State University's NASA's Goddard Space Flight Center. Now, Hiren has a very interesting career. He grew up in India, went to the US, studied in US, and his specialization is monitoring of aerosol using satellite and ground-based instrument. That's what Hiren does. And Hiren, this year, was the person who basically came out and said that farmers were actually burning their crop when the satellite monitoring was not happening. Essentially, the satellite which we use to monitor stubble burning passes over India and Pakistan between 1:30 and 2 p.m. Now, somehow, this information was given to farmers in Punjab, Haryana, and Uttar Pradesh. And therefore, they were burning their fields at around 4 p.m. when there was no satellite monitoring. Now, Hiren raised this issue. It became a national news. But I also want to point out that this issue was also flagged this year in January by Remote Sensing Agency of Haryana in a meeting done at the Commission for Air Quality, which has been set up in Delhi. So I do not believe that the authorities were not aware of this fact that farmers were cheating the satellite monitoring. This fact was known. So let's dive into this discussion. let's understand from Hiren how he came to this conclusion, and then understand from him how do we improve monitoring of stubble burning in the country. So thank you, Hiren, for joining this conversation. You come from which place, Hiren?
Well, originally I'm from Gujarat, and I did my Bachelor of Engineering in the mechanical discipline in Vallabh Vidyanagar,
Anand.
which is, Anand. Yeah.
Yes.
So, and then I did my Masters and PhD from Indian Institute of Science, IISc, Bangalore,
Yeah.
in atmospheric science. And then I moved here in 2009 to do my postdoctoral research at Hampton University in Virginia.
Okay.
I spent there about 2.5 years, and then I moved to NASA Goddard here as a research scientist. And since 2011, yeah, towards the end of 11 till now, I'm still with the same place, doing the aerosol, cloud remote sensing, air quality stuff, biomass burning. Those are my prime research areas.
So biomass, that is where you have started looking at stubble burning, right?
Yeah, I basically, this stubble burning has been my like side interest. I was never funded to do this work here because my main job here is to do the aerosol remote sensing from the NASA satellites. So we are basically developing the algorithms uh, uh, and then retrieve those satellite products, validate it, analyze it, and put it in the public domain. So we use different satellite UV satellites, sensors carrying the UV wavelengths, the visible wavelengths, even near IR wavelengths. So those are our spectral ranges of retrieving these aerosol properties. But I was following this stubble burning in northwestern India since 2015.
Okay.
I started following every year, and then it got me, more involved in those events. And eventually, I published 3 papers on that subject. The first paper, I think it was in 2018. We analyzed this PM 2.5 from US Embassy, New Delhi site. And also we looked at the satellite data for like 3 or 4 years at that time, starting from 2013. Basically, we tried to see this pollution, how much pollution level is there over Delhi and overall over the northern India. So it was all about analyzing this whole stubble burning event from different perspective, from the ground, from the meteorology point of view, and using the satellite data, including the LiDAR. The highlight of that paper was that the Delhi's air pollution during the October and November is mostly contributed by the stubble burning in Punjab and Haryana, both states. Because Delhi is just, the next city. Stubble burning in Punjab, which is about 450 kilometers away from Delhi, but because of the wind pattern. So we looked at this back trajectory, what we call back trajectory analysis. We start from Delhi and we go back in time, 2 to 3 days, and see from where those air mass was coming. And we found out that the most of the trajectories, came from the Punjab and Haryana to Delhi.
So that essentially proved your point that during October, November, air pollution in Delhi is significantly impacted by stubble burning.
Yes, stubble burning, yes. And then we looked at the long-term record of the fires uh, in Punjab and Haryana, and we found a positive trend. It was about 600 fire counts per year increase from 2002 to 2016.
So essentially, so what you found was that in 2002, the fire levels were low, but it was increasing every year.
Almost, yes, monotonically. There were some slight dip during certain years, but overall, if we just fit a linear curve, linear trend in the time series, we found about 600 fire counts per year increase.
Okay.
So over 16 or how many years? It was more than 12, 14 years. If you just multiply that number, it's a huge
to
number.
10,000. Then it's about 10,000.
Yeah, so total, yes, there was no doubt that the fires were increasing. And then in the next paper, we asked this question that why there is a trend, this very strong positive trend in the fires. I looked at this crop production data from the Department of Agriculture in India. So I extracted those data thanks to the Department of Agriculture, Government of India, that they put this crop production data at district level and also the state level for every state and every district in India. So it was very easy for me to extract those numbers from their data center, and we found that there is also an increase in the crop production by 25% over this
Absolutely.
2002 to 2016. So if there's more crop production and there's more crop residue generation, and I did some literature survey on this because I'm not an agricultural scientist, so I had to do this literature survey to figure out this crop the actual crop amount and the actual crop residue amount. And it looks like if we have 1 million ton of crop production, the actual crop production, then it generates about 1.7, 1.8 times, like 80%
Yes.
more crop residue generation. So there's a lot of leftover. Once they harvest this crop, there's a lot of almost double the crop amount is left over on the ground. And we also looked at the satellite data of vegetation index, which tells us about the how green is your land cover. And we looked at this vegetation cover before the burning season started. So to just look at the when the crop is matured and it's about to be harvested, so it's lavish green if you look at the satellite data. And we also found that there is about 20 to 22% increase in the vegetation cover
Cover.
over this period of time from 2002 to 2016.
So the
So all
second,
this
the
different,
second
yeah,
reason you found was that as crop production is increasing in India, the residue is increasing, and therefore farmers
yes,
are disposing more and more residue through
more
fire.
and more residue. Yes, so that the 2019 paper was about connecting these different dots here. So we first of all we started we looked we realized that the fires are increasing. Okay, about 600 fire counts per year over Punjab and Haryana together. And then we asked this question, we went back that what has happened, and we found that the crop production has increased, which is supported by the satellite vegetation index data. This were the data from satellite, from the ground, from the Department of Agriculture, this crop estimation, everything were making sense to me. Then I thought that why don't we compare the vegetation data directly with the number of fires and bypassing the crop production, because vegetation data is a proxy for the crop production. We still don't know the crop production. The crop production data will come after several months of the after harvest. It takes time
Yes,
for
of course.
government agencies,
Yeah,
yeah,
yeah. They put together data before it is available.
yeah, exactly. So what I have at the beginning of the season is just the vegetation data from our NASA satellite. So if I can compare that vegetation data directly with the fires,
Hmm.
then there is a chance there to predict
How much
the
fire will happen in the next season?
yes, the intensity, the totality of the
Hmm.
fires that we're gonna see in October and November. And surprisingly, we found a linear relationship between the vegetation data and the totality of the fire, the seasonal total number of fires. So based on that very simple linear regression model, I developed a prediction model to predict the totality of the fires that we're going to see in October and November. And that was working really well. So I used this model to predict the fire season for 2017, 18, 19, even 21. And my predictions were about 95% accurate.
Are you surprised that despite so much research, there is still a debate in India that whether for farm fire is contributing to air pollution in Delhi?
Yeah, every year, since I think 2018 or 19, I have been called to this Indian news media channels, particularly on NDTV, and every year we discuss the same thing. And there is still a lot of debate there that whether
Farm
the
fire is
stubble burning
contributing.
is impacting the air quality in Delhi and downwind region. There is no doubt about it. All kinds of analysis, research, and data they show that the Delhi's air quality, at least during these 2 months, particularly the last 2 weeks of October and the first 2 to 3 weeks of November, Delhi is really influenced by the stubble burning, smoke transport from Punjab and Haryana. There is no doubt about it. Yes, on a particular day, if you look at the model results, on a particular day, depending on the wind speed, depending on how many fires are there on that day, uh, that contribution, the percentage contribution varies little bit here and there. Yes, may sometimes 40%, sometimes 50% or more. But overall, for this 5 to 6 weeks, there is no doubt. Since I published that paper in, I think it was 2021 or 2022, and then as usual, every year I put forward my this prediction on Twitter. And since 2022, I noticed that my prediction is coming up higher. So when I compared my predicted number with the actual fire counts at the end of the season, my predictions were higher, but the actual fire counts were lower. So that happened in 2022, 23, and this year. Initially, I believed that, yes, this is a very good result, although my predictions are failing. But this is a good result because there must be some ground action taking place in Punjab and Haryana to reduce these crop burning events, which is a good news, right? That was my assumption at that time. But this year I found out that's not the case. We were in delusion since last 3 years that the fire counts are going down. In one way, yes, it is going down. When you look at this widely used NASA satellite data, which overpassed the region at 1:30 p.m. But what has changed from 2022 is the timing of these fires. If you look at the past data up to 2021, the majority of fires were taking place around 1:30, between 1 to 2 p.m. Okay, so the satellite were able to measure the totality of the fires, the majority of fires during that time window. But now it looks like that the farmers have changed the burning timing from about 1 to 2 p.m. to about 4 to 5 p.m. So there is a 2 to 3 hours of delay. There is no doubt about it. I have strong evidence from the geostationary satellite data. So this is the first time I started looking at the geostationary data from South Korea, because that data was available to me. I also tried to look at the Indian the INSET data, but I'm not sure about its data availability to other users.
Okay.
So, but this data was already all those nice animations, images online, and later I was also able to access the actual data, and that was really fascinating. That if you look at their satellite animation of what we call this thermal infrared signal at 4
Yes.
micron, which is primary channel, which is a primary channel even for the NASA satellite and NOAA satellite. The 4 micron is the primary channel to detect the thermal signal, and the South Korean geostationary satellite with AMI sensor, the Advanced Meteorological Imager, it's that sensor is quite similar to the NASA, the MODIS and VIIRS sensor. They have similar channels, wavelengths. It was wow, quite surprising to me that when I just look at the animation, you don't see the thermal signal up to like 3 to 4 p.m. and suddenly there's a burst of signal at about 4 p.m. and that continued to 5 and 6 p.m. too. But there were very
Essentially, farmers were found a loophole in the system. Someone told them that burn after 3 p.m.
yeah.
so that no one can detect if you're burning.
I will come to that point, and then I was surprised, and I was putting those animations and images on Twitter, and that became the major discovery this year. And even uh, I was in delusion since last 3 years that my predictions are failing. In one way, I was happy, and I mentioned that in my paper also, that this prediction model would be very useful to even track this ground actions on reducing the stubble burning. Because if my prediction is higher than the actual fire count, that means
The
the difference
interventions have
could be
yeah.
attributed to the ground actions and policies. So that prediction model was helpful in both ways, when it gets success and when it gets failure, both way. But I was kind of fooled by this shifting in the time of burning. And then again, from other official, non-official sources, from the word from different mouth in India, I heard that the farmers were instructed to not to burn around noontime or afternoon time, but they can start igniting fires after 4 p.m.
Okay.
Now that 4 p.m. I can exactly see in my data. You see, okay, after 2 p.m. there is a 3 p.m. This satellite data is at every 10 minutes, but I'm analyzing it on hourly basis to reduce this computational time. So 3 p.m. you see some signal at 3 p.m., but 4 p.m. there is a sudden rise in the fires, and now that 4 p.m. Quite matches with what I've heard from news
People.
media and other people. Uh, and that was like very surprising to me, that how farmers know this satellite over past time. And what I heard also that, I mean, farmers have more information, like a scientist have that information, and that's somewhat unusual for farmers to have that kind of detailed information.
I
That
think
what
I think
satellite? Yeah,
they must have, someone within the system itself, those who are monitoring farm fire must would have told them, okay,
yeah,
that
yes,
information would have spread for them. Yeah, that
yeah,
could be the reason.
yeah. So I mean, see this. No one will just raise their hand and say that, well, yes, I did it. I informed the farmers. So no one will tell that. But it's just the word by mouth from some
Yeah.
officials,
Word of
some
mouth
people within the
connected.
system.
Right.
Yeah, within the system, that they have been trained. And actually, that has happened. That has happened not just this year. If you look at the fire trend, it is coming down. If there is a downtrend starting in 2022, and then it further
23.
continued in 2023 and 2024. So there is
In
a
fact,
sudden.
no, the government data shows that the farm fire has reduced by 80%
I
from
mean,
the peak.
yes, even I can say that. But if you just look at the NASA satellite data around 1:30 p.m., okay, we don't know what is happening before and after. Now we have some means of knowing what is happening before and after that 1:30 p.m. over past time. And I have a very strong evidence from this geostationary satellite data. And since last 1.5 months, I have been continuously working now to basically derive at least the first version of the algorithm using the geostationary satellite data to detect those fire hotspots. I'm almost like 80% done.
It means that from your research, it is clearly two things are very clear. Okay.
Yeah.
Number one, that this entire discussion that happens every winter, that whether farm fire is contributing to Delhi's pollution, shouldn't happen. It is established fact.
Yes.
The number two that comes out is that the farm fire is not reducing as per the government data. So do
No.
you think actually the farm fire is increasing?
Okay. So yes. If you look at the satellite, the widely used satellite data up to 2021, either it's at a stable level or slightly increased. There is no
Okay.
doubt about it. Now the question is about last 3 years. So
Mhm.
if you look at the same satellite data, there is a strong downward trend.
What does aerosol optical depth tell us about it? Because we also have data on aerosol optical depth.
Yes, of course. So I just put one very long-term time series on Twitter, uh, and I'm showing both the aerosol optical depth from satellite and the fire counts in the same chart. So for aerosol optical depth, I consider this whole northern India region, what we call Indo-Gangetic Basin or
Mhm.
Indo-Gangetic Plain. That includes Pakistan, Punjab, Haryana, UP, Delhi, and even the eastern part of India. And I looked at this long-term aerosol optical depth and also the fires in Punjab and Haryana together. So you would see that the fires are coming down after 2021, yes. But the aerosol optical depth is either maintained at the same level or it has increased. Actually, this year in 2024, I looked at the 4 weeks of November. The aerosol loading was highest seen in last one decade, more than one decade, since 2012.
And that
This
we can
November.
experience. I mean to say the air pollution levels during
Yeah,
October in Delhi was really, really bad.
yeah,
We
yeah.
had continuous days of severe air pollution.
So in October, I was looking at the weekly data, like weekly average, and if you combine both October and November together, I think this year has been the most anomalous since last 12 years.
What changes should we do in our monitoring mechanism for farm fire?
Okay, very good $1 million question. Number of fire counts. is not going to be the major measurement metrics. Okay, because that is fooling us. That's incomplete. What we are seeing around 1:30, that's where not the fires are taking. Fires are taking place much later. So that's a second. This is going to be a secondary measurement matrix. But the first one would be the burned area.
Mm-hmm.
Okay, farmers can hide the fires from the satellite, not completely. If you look at the geostationary satellite data, but at least from this afternoon satellite overpass time, they can hide, but they cannot hide the burned area.
Yes.
Okay, that will be seen next day when the field is burned. Okay, that part will be seen next day by the morning satellite, by the afternoon satellite, a series of other European satellite also with very high resolution mapping. So that can be seen, and also the air pollution loading. They, we can't hide smoke. Smoke, whatever you burn, it will be seen next day by the satellite. So
Okay.
and not
That
just
is
at one place.
aerosol optical depth.
Aerosol optical depth, yes,
Okay.
yes, and we have now numerous ground network of PM 2.5 in that region, right? In Punjab,
Yes, of course.
Haryana,
In
Delhi.
every more or
So it
less
will be
every
seen,
major
yeah,
city.
yeah. So it will be all seen in the PM 2.5 data, okay, and as well as satellite data over the whole region. So in order to really quantify, not quantify, to monitor basically this pattern of the burning, we need high resolution satellite data, geostationary satellite sitting over India. Now, going back to my earlier point, India has INSAT satellite with this 4-micron channel, and I also looked at their images. The IMD has a web portal called Rapid, where
Mm-hmm.
they rapidly disseminate this recent data, what
Mm-hmm.
we call near real-time data of the Indian satellite. So, yeah, there is a hope of using the INSAT satellite data too at half an hour, at least we need every 1 hour snapshot of satellite data. But again, that won't be complete because at 4 kilometer, for example, we have 4 by 4 kilometer grid, okay, and that's the one pixel, that's the one measurement from the
Yes, of
satellite.
course.
It will just give you one value, okay. Now, if there are some small scale fires are happening within that 4 by
You will
4,
not be able to capture.
it won't be able to seen or felt by the satellite data. For the 4 by 4 kilometer to be effective in identifying the fires, there should be a strong signal. And remember, this thermal signal is not just about the fire hotspot, but it's also detecting the hot smoke. Because once
Mm-hmm.
the fires releases the smoke, it is hot, very hot. So that also emit the thermal signal. So what we are seeing is both the hotspot, the actual fire, as well as the hot smoke. So they are the technicality of these measurements.
No.
So at higher resolution, we can see the fire hotspot, the burning hotspot. But with the coarser resolution, we see both the smoke, the hot smoke, as well as the fire spot within that 4. So
4
unless
kilometers.
there are sufficient number of fires and smoke in that 4 by 4 kilometer, yes, then we can see. Then we can see that signal in the thermal measurements. But if there are isolated fires in that small region, then we are unable to see.
So
That
can we say that therefore, for us in short term, first of all, let's measure burnt area.
yes,
Okay, that is number one.
that's
Number
number
two
one.
is, and then side by side, use the geostationary satellite,
Right.
whether our
Yes.
own or South
Yeah.
Korean satellite, to
Right.
get coarser resolution,
Right.
to get some coarse idea on whether the farm fire is
Right.
increasing or not.
Increase. Yes.
Both of them we should do both,
Should
right?
be. It should be. Yes.
This prediction is also done by SUFFER, which is
Yes.
Indian
Yes.
Institute of
Yeah. I
Tropical
know. Yeah.
Meteorology. How accurate are their prediction?
Good question. Well, I'm not a modeler. I haven't used that. I haven't used these their model prediction so far. But they say on a very intense burning days, the contribution of the stubble burning to Delhi is about 40 to 50%. But I doubt those numbers are still underestimated. I have some collaboration. Actually, my colleague here at ANCAR, who is a modeler, who is part of this SUFFER team, their simulations this year are failing. of predicting this PM 2.5, the pollution level, because they are not seeing much fires in the afternoon satellite data, and that's what they use to assimilate, to feed to the models. And since those are very low, they are not getting enough pollution in that model. So that's why they also wanted me to give this geostationary satellite data, so that they can adjust their
Model.
emissions and the timing of the fires in their model.
Do you see actually, because one of your job is to also look at biomass burning?
Yes.
So the question I have is, do you see this farm fire increasing in other states as well now?
Good question. I haven't looked at the fires in other state in details, but now I think someone should look at this fire pattern all over India.
Some of the data that we have been looking at iFOREST clearly shows that farm fire is no more an issue only for Punjab and Haryana.
That's
We
true.
are seeing a lot of farm fire in Uttar Pradesh, Madhya Pradesh, even
Madhya
Odisha.
Pradesh. Yeah.
Even
So these are the three. Yeah. Even I looked at at least visually on the images. I haven't extracted the data myself, but it's there. It's there in my data. But since the always focus was on Punjab and Haryana, I was maybe a little biased towards that analysis. But yes, there are fires in, I agree, Punjab, UP, and even Madhya Pradesh and Odisha. And those fires, because the wind pattern is slightly different. If you see the satellite images, the whole, even Maharashtra, even in Andhra, you see the fires.
Yes, of
So
course.
if you look at the satellite picture, there's a huge, very wide blanket of smoke covering the southern parts of India. It's affecting the air quality in Delhi. Sorry, in Mumbai.
Why?
In Mumbai have measured the contribution of those, because the winds are easterly, so it flows from east to west. So whatever we burn in the central India, in Maharashtra, in parts of eastern, basically the smoke travels so across this peninsular southern India, and it goes over like Mumbai, and then it flies over Arabian Sea. And I have seen this smoke plume reaching Somalia, even
Really?
Africa. Yes. Okay, satellite. Just look at the satellite data day by day, and you see it's a very low-level smoke plume. It's not very high, but what we burn in central India, it reaches to Africa, Somalia, and what we burn in Punjab and Haryana, it reaches to. Of course, it covers the whole Indo-Gangetic Plain, and then it goes to the southward in Bay of Bengal, and again, since the winds become easterly from that latitude onwards, okay, it overturns, and it sometime it even I have seen the smoke plume reaches to Chennai. What we burn in Punjab, it is seen in Chennai.
So you are saying that this smoke is hitting Arakan, which is
Yeah.
Arakan Hills in northeast.
Yeah.
And then it is moving southward and polluting Chennai.
Yes. In certain on certain years, on certain days, yes. Yes.
No, it's
It
very
pollutes Bay of
interesting because
it pollutes Bay of Bengal. There is no doubt about it. It pollutes Bay of Bengal.
okay.
Because that's how this geographically, that's why we call this Indo-Gangetic Plain, because we have very tall Himalayas in the north, and we have the ranges of these Vindhyas
Yes.
in the south. So between these two mountain ranges, it forms a channel like geographical region.
Yes, of course.
So, and because of the colder temperature inversion, the smoke layer is still it remains within the first maybe 500 meters, 1 kilometer altitude. So everything is flowing within bounded by those two mountain ranges and at low level. So that's a channel. Basically, the channel helps the smoke to move from northwest to southeast. It goes to over Calcutta, even over Bangladesh, and then it turns southward. And after that, the easterly wind takes that smoke to the eastern shore of India, and sometimes even Chennai.
No, it's very interesting. All your three papers are essentially telling us that the debate over this entire debate, whether Punjab and Haryana farm fires are affecting their air quality or not, should stop.
Yeah.
It does, number one.
Yes.
Number two, there's a strong evidence that the farm fire is not reducing. And
No.
we are hoping to see your new paper, which will tell us whether the farm fires are actually increasing or not.
Yeah.
There is
I
evidence.
have, yes. Yes,
There is
that's even I'm also very excited to see.
So the second is that it is not reducing, maybe it is increasing. We are looking forward to your paper. And
Yeah,
number three, which is what our last discussion was, that actually this farm fire in Punjab could be affecting air quality as far as Chennai.
yeah,
Obviously, it is affecting the entire Indo-Gangetic plain.
no
And
doubt.
the
Yeah.
farm fire in central India is affecting air quality in places like Mumbai. And you
Oh
are saying
yes,
that the pollution plume could be going as far as Somalia, and
yes.
it's heading up
Across Arabian Sea, across the Arabian Sea. Yes,
across the Arabian Sea to Somalia. So these
yes.
are absolutely, fascinating discussion. And you have also recommended that we should be changing the measurement method
Yeah,
on fire.
India, I think, is high time now to have this air quality mission
Yes.
from ISRO. ESA has, the European Space Agency has this, Korea has this, China has it, US of course has this
So
very
we should
high
send our own
resolution.
satellite.
We should have, India should have our own satellite air quality mission with the fire detection
Absolutely.
at higher resolution.
As a country, as a developing country with aspiration to become a
Of
developed
course,
country, India should have all these things that other countries.
I think we need one air quality mission looking at the aerosol particle, looking at the trace gases like ozone, NO2, formaldehyde, and with the fire detection capability. And you know, Europe has developed those algorithms. NASA has, so we can always collaborate. Basically,
No, absolutely.
India doesn't. ISRO doesn't need to start with the scratch. There are algorithms already available.
Let me thank you.
Sure.
It has been a fascinating discussion. Your journeys over the last, decade,
Yes, now
has
it's a
been
decade. Yes.
equally fascinating, and it has contributed to
Oh,
our knowledge on air pollution in India. Thanks a
thanks.
lot for joining me in this conversation. It has been an excellent, conversation, both from the perspective of your journey as well as understanding what is happening actually with farm fire.